So, yesterday, we made this final decision of the content of the speech, and we decided to go for the, well, certain kind of compromise. We're going to show you something. We're going to show you some, well, we're going to start with telling about this whole research project. We're going to tell about the hard work that we have put together, and we're going to show you some key findings. But we also want to be these good citizens, and we want to not to cross the line where we would endanger all those good folks that are using the vulnerable IPS and next generation firewall products out there. And also, we do not want to finger point any individual vendors. We do not want to name them. We have blurred out all those vendor names in our framework talk. I'm assuming that the term evasion is pretty well known to the audience in this room today. As simply put, it means a method to disguise a network attack in such a way that a security device that is between the attacker and the target host doesn't recognize or doesn't interpret properly the traffic to see the attack or the exploit payload that the traffic contains. We like to use the analogy of the stealth fighters that are invisible in the radar. I would like to stop briefly here to speak about the significance of the evasions. It might be obvious for you guys, but clearly it's not to everybody out there, that the evasions are not just yet another exploit. And therefore, they cannot be fixed by yet another signature in an IPS signature base. But the fixing of these things take a lot more work. If I a little bit open up this problem of the evasions, I'm using as an example of the MSRPC protocol, which is a Microsoft-based protocol used for multiple purposes, like for file sharing, remote procedure calls, printing, authentication, probably some other things that I'm not either aware of or just can't remember now. The MSRPC protocol can use multiple different carrier protocols. The IPv4, IPv6 are very obvious. It works on both of TCP or UDP protocol. Also, it's possible the standard says that it's fully supported to run the MSRPC on top of HTTP. And then it works on the top of the NetBIOS and SMB protocols. It's also possible to bypass the NetBIOS layer and run the SMB protocols on top of either TCP or UDP. So this means that if we have an IPS product that has evasion vulnerabilities in any of those carrier protocols, then an exploit, an MSRPC exploit, can be slipped through this IPS without detection and without determination. These highlighted protocols, IPv4, TCP, NetBIOS, SMB, and MSRPC, are those protocol families or those concrete protocols that we have put our research efforts. And that's what we're going to speak today. Also at this point, this demonstrates that the whole problem area of the evasions is a lot larger than we have been able to do so far. And that's one of our key messages we want to give to the community, which is that we can't study them all alone, but we are encouraging the others to join the force. At this point, I would also like to play with some numbers. I'm estimating, as an IPS vendor, I'm estimating that the average new signatures that IPS devices are getting every year is somewhere in the neighborhood of a couple of hundreds, like 200, 300, 400, about that amount of signatures every year. Which means that for an IPS that has been in the market for several years, it's pretty safe to assume that, that they have like several thousands of signatures, just like our project has, and like those projects that are telling these numbers out publicly. It's also very safe to assume that all those attacks that these IPSs are giving the protection against with those signatures are IP-based. So that means that if the IPS device is vulnerable to an evasion on an IP protocol layer level, then the attacker can bypass any of those exploits that this IPS is supposed to protect against. And it's almost the same thing for the TCP. The percentage goes, of course, a lot lower when we are starting to speak about MSRP, so that there are problems in every single layer in the modern IPS devices out there. And that's what we are publishing. The answer to this, well, that's something that the IPS vendors need to do, or the next generation firewall vendors, or the UTM vendors, is to do the proper normalization. If the IPS, if that security device constructs and reassembles all the traffic, every single layer of these protocols together exactly the same way as the endpoint is going to do, then you're safe. Next, I would like to start to discuss about this, our own finding. Like I said, my story is a combination of something old and something new. The old stuff is what we have been covering so far. The newer stuff is this that we have been doing, and that what we haven't been publishing that much of before a couple of weeks ago when we started. The Predator tool is a tool made by Antti Levomäki and Olli-Pekka Niemi and their team. It's an evasion testing framework. It consists of close to 80,000 lines of code. It has its own TCP/IP stack. It's an evasion testing tool. It tests, we call this as a live testing. There's no any simulations there. There's a real tool, a real attacking tool, the Predator, and we are using a real image of a real victim. So we have a Windows host that is vulnerable to certain exploit. And then we put these different IPS devices, our own included, of course, to the between. The current version has about 180 different evasions, all the old and new technologies combined together. There are some calculations; those are very simplified, of course. It's not possible really to combine like every different kind of evasions together, but they signify something about that. The whole problem area is huge, even with these protocols that we have here today. I want next to tell you something about what happened to us last year, pretty much about 1 year ago. At that time, we had been studying for these evasions for some time, and we thought that we were pretty good at that. And so, when we submitted our IPS with the NSS lab testing, while we were nervous, I suppose every vendor is nervous when they submit things to the test labs. We were worried about the throughput numbers. We were worried about if there are any exploits that we can't catch. We were worried about the false positive rate and that type of things. But we were pretty confident about evasions because, that was something that we thought that we knew about. We were pretty shocked about the results. We failed miserably the evasion test. We actually got pretty good score on those other parts, but we failed the evasion part. We got something, of course, but there were even on TCP level, there was something that we just missed. We put more resources to the engine programmers. This day, Stemsoft has 50% more engine programmers than what we had a year ago. We also put more resources to the research of the evasions. We still wanted to do that more. And so a decision was made. We started to buy our competitor IPS and next generation firewall products. We started that early this year. We selected them from the leading vendors. I don't want to give the vendor names, but pretty much everybody from the partner Magic Quadrant, challengers and leaders bought were selected. We also selected somebody else. Well, some other vendors, focusing on those that had been bragging publicly about their ability to block the evasions. So we also made sure that we're running the latest of the versions. They're continuously updating their signature bases and that type of thing. So we're running them pretty much like the real customers would be running this. I like to categorize the evasions to 3 different categories. First, we have those old evasions that have been in a tool format that still are in a publicly available tool format. Secondly, we have the evasions that we have seen some academic studies that have been mentioned in the speeches, maybe even in an in-depth way, but that we haven't seen any publicly available tools, free or commercial. And thirdly, we have a handful of evasions that we haven't seen anywhere. It's possible that they have been discussed somewhere, but we haven't seen them anywhere. And so, it shouldn't be a surprise that when we started this testing, that these only known to us evasions were pretty powerful. We call them as master keys because they work against every single vendor in the market. We also noticed that the vendors had a lot better ability in blocking those evasions that exist in an available tool format. But it's not so that every vendor would block them all. There are vendors who can fail to an evasion that has been in a tool format for 12 years. Okay. I can't be more specific with this because we don't want to give the vendor names. But remember, there are the top vendors. I'm not sparing ourselves either. We also found that when we started to combine the evasions together, the success rate increased dramatically. It was possible to go through. We might have an evasion 1 that doesn't work. We might have an evasion 2 that doesn't work. And when we put them together, they just go through. And then there was an interesting finding. So far, in our industry, the best quality of a testing tool is a good quality traffic capture file that has the working exploit. And by replying that to the network, we can test if the IPS can block that or not. We found something interesting which says that this is not always the case. This is not a reliable test in all cases. We found a single vendor, definitely I'm not going to tell the name, but we found a single vendor that is vulnerable to a live testing, even though the traffic capture test of the very same test seems. This is how it tool works.